This lesson is on rational and irrational square roots. The square root of a number is the value that when multiplied times itself gives the number, which is kind of a strange definition when you just look at it, but when you look at the example, it's pretty basic. 4 times 4 is 16, so the square root of 16 is 4. And the symbol we use is this radical symbol, so we say the square root of 16 is 4, because 4 times 4 gives you 16. Perfect squares will have whole numbers for their square roots. For example, the square root of 36. What times itself gives you 36? 6. So since 6 times 6 is 36, 6 is the square root. If we look at the square root of 100, 10 times 10 is 100, so the square root is 10. The square root of 25 is going to be 5, because 5 times 5 is 25. X squared. We talked when we were factoring about how x squared is a perfect square. What times itself gives you x squared? It's x times x. So the square root of x squared is x. When you have a monomial like this, you need to take the square root of each piece. So the square root of 4 is 2, and the square root of x squared is x. 4x squared is 2x times 2x would give you 4x squared. So 2x is the square root. The square root of 1, since 1 times 1 is 1, that's our square root. Fractions should be simplified before you find the square root. The square root of 36 over 9. Well, 36 divided by 9 is 4, so this means the same thing as the square root of 4. And the square root of 4 is 2. 200 over 32. Well, both of those are divisible by 2, so I would start by simplifying there. 200 divided by 2 is 100. 32 divided by 2 is 16. Those are both divisible by 4, so I can simplify a little more. I get 25 over 4. And then you take the square root of the numerator over the square root of the denominator. The square root of 25 is 5, and the square root of 4 is 2, so that's 5 halves. 75 over 300. Both of those are divisible by, let's see, 25 is the first thing I see, so I'm going to go ahead and start with that, and I get 3. 25 goes into 300 12 times. That simplifies again to 1/4. The square root of 1 is 1. The square root of 4 is 2. So that has a square root of 1/2. 18 over 32 simplifies. We can divide by 2 and we get 9 over 16. The square root of 9 is 3 and the square root of 16 is 4. So that has a square root of 3/4. The square root of a decimal can be made simpler by changing it to a fraction instead. So we have the square root of 0.09. Read that out loud to make it a fraction. So this is 9 hundredths. So we say the square root of 9 hundredths. That doesn't simplify. We just go ahead and take the square root. The square root of 9 is 3. The square root of 100 is 10. If you want to change that back to a decimal, then you can. It's 3/10, so 0.3. When you have a negative out in front of your square root sign, that's like saying -1 times whatever the square root is. And since the square root is positive, when we do negative times positive, we're going to end up with negative. So our final answer is going to be negative something. If we read this decimal out loud, that's 64 hundredths, so negative square root of 64 over 100. We could simplify that now, like we did on the previous slide, or if you want to go ahead, since they're both perfect squares, and say the square root of 64 is 8, and the square root of 100 is 10. We have -8/10, and we can change that to a decimal, -0.8. For this next one, we have 2 and 25 hundredths, so we can say the square root of 225 hundredths, and go ahead and take the square root there. You can simplify first if you want, or go ahead. The square root of 225 is 15, and the square root of 100 is 10, so that's 15/10 or 1.5. The last one, It's a negative again, so our answer is going to be negative. So negative the square root of 25 hundredths. The square root of 25 is 5, and the square root of 100 is 10. So that's negative 5/10, negative 0.5. Remember, when there's a negative before the radical, just apply the negative to your answer. Some square roots can be simplified but do not have whole number values. Like for this one, the square root of 75, nothing times itself gives you 75, and since it's not a fraction you can simplify, we're going to need to figure out something else. Let's look at the square root of 100. We know from earlier in the video that the square root of 100 is 10. But I'm going to show you another way to find that. 100 has two perfect squares in it. It's 25 times 4. So I can break that up and say the square root of 25 times the square root of 4. Well, the square root of 25 is 5, and the square root of 4 is 2, and 5 times 2 is 10, which we got in the beginning. So what we're doing with these when they're not perfect squares is looking for perfect square factors. 75 has what perfect square in it? Well, we're going to look at our list of perfect squares. We need to remember 1, 4, 9, 16, 25. 25 goes into 75. So we can say that's the square root of 25 times 3. Now when we break it apart, the square root of 25 times the square root of 3, the square root of 25 is 5. 3 is not a perfect square, so we're just going to say 5 times the square root of 3. And you're going to have a lot of answers that end up looking like this because most numbers that you deal with are not perfect squares. When you do the square root of 200, I notice that's 2 times 100, so I'm going to do 100 times 2. Well, the square root of 100 is 10, and then we have the square root of 2, so we have 10 times the square root of 2, since we can't simplify the square root of 2. Negative the square root of 32, that's a negative, so our final answer is going to be negative. What perfect square do you notice is in 32? It's 16, so it's 16 times 2. The square root of 16 is 4, and we can't take the square root of 2, so negative 4 times the square root of 2. The last one on this page, we have negative again, 27. What perfect squares go into 27? Well, 9 goes in, so I'm going to say that it's 9 times 3. The square root of 9 is 3, and we can't take the square root of 3, so it stays inside. And that's how we're going to simplify those.